I'm Brent Stafford, and welcome to another edition of RegWatch on GFN.TV. Are nicotine, vaping, and other risk-reduced products the answer to the scourge of smoking-related disease and death? Since the 7,000 chemicals and 70 carcinogens found in combustible cigarettes are known to harm nearly every organ in your body, one might think the answer to this question is simple. But despite mounting evidence showing nicotine vaping products are relatively safe and effective, confusion around the science continues. Joining us today to discuss the science on vaping is Dr. Marina Murphy, Director of Scientific and Medical Affairs at ANDS and former Head of Scientific Media Relations at British American Tobacco. Dr. Murphy, thanks for joining us today on RegWatch.
Thank you very much for having me.
Oh, it's our pleasure. You know, we host public health scientists all the time on this show, but your specialty is chemistry. Tell us about your background and what was it about tobacco science that you found most interesting?
Well, as you said, my background is in chemistry, and several years ago now I did a research-based PhD in Ireland, where I'm from. There was a question then, and it remains a question now, as to the link between aluminium and Alzheimer's. Because aluminium collects in the brains of people with Alzheimer's, and there's a question as to whether it causes it or it's a result of a person having Alzheimer's changing the brain so the aluminium can't pass out. And while that's an interesting question, it wasn't the question that I was trying to answer as a scientist. I was looking at what the potential dietary sources of that aluminium was. And as part of that, I did some research on the dissolution of aluminium. Because aluminium, as you know, continues to be used in storage for food items, but it was also used a lot in cooking pots at the time. And, students like me at the time would actually have aluminium cooking pots at home where you could see the pitting corrosion at the bottom. So basically, the research that I did showed that the tiny amounts of fluoride added to water, when that water was used in cooking, in combination with high temperatures and chloride, produced very soluble compounds that weren't produced when you had high levels of fluoride. And because those compounds were soluble, you didn't get a kind of a rust building up like you do on iron to protect the metal. So the metal was exposed, and therefore that metal went into solution very rapidly and just kept dissolving, so that you ended up with water with more and more aluminium in it. And I suppose, when I was doing that, I didn't think I would end up working in tobacco science, but I have ended up doing that. And probably one of the reasons is because I am a chemist, and because chemistry is so surprising, and it often does things that you don't expect it to do. Like, for example, if you consider the aluminium a situation, you might think, well, if something is going to be dissolving the aluminium or causing it to dissolve, well, then adding more should make it dissolve more. But in fact, it's the opposite. Having less makes it dissolve more because of the nature of the compound that you produce in that situation.
And that's interesting. So take us from doing that research to how did you end up working for British American Tobacco?
Well, I suppose after you do a lot of research, you spend a lot of time reading and a lot of time writing, because you have to produce a lovely thesis on the basis of which you are judged. And I have to say, I actually did really like doing that background study and doing that research. And so after I did my PhD, I decided that I would quite like to be a science journalist, because there weren't that many science journalists, and the science journalists that there were didn't have a scientific background. So I went back to university and I studied science journalism. And then after that, I spent the best part of 10 years being a reporter, an editor, a commentator. And I worked for, very well-known outlets like BBC Science, New Scientist, Irish Times, things like that. And then I came across this company called British American Tobacco that were looking to set up a science communications function. And like a lot of people, I was aware of brands, but not aware of companies per se. So we've all heard of Lucky Strike, we've all heard of Marlboro, but not necessarily JTI, Imperial, or BAT. So to me, this company was very much an unknown. But I was also aware of the concept of tobacco industry, or we'll say big tobacco as it's called, despite the fact that I did not necessarily know who the companies were. So I was surprised to find that this company, part of Big Tobacco, wanted a scientific communications function, because I thought, well, what science are they communicating? And the other thing I thought was, well, why as a science journalist myself for many years, why was I not aware of this? So I like to think of myself as a sensible, pragmatic person. So I was interested. I was interested to find out. I was interested to talk to them, and I did. And I suppose you could say the rest, as they say, is history. I went to work for them and helped them to set up their science communications function.
I'm getting the sense you had no idea that Big Tobacco was interested in science. What was your impression as a science journalist about tobacco companies?
I suppose I didn't have an impression of them as an R&D, we'll say, based or focused type of industry. I didn't have the impression of them as companies that would hire lots of scientists or publish papers or want to talk about science. And I mean, I did cover science broadly. So I covered lots of different sectors. I covered the pharmaceutical sector, chemicals, energy, materials, agricultural science, you name it, covered everything and all the companies that were involved in those sectors. But I had never, in the whole time I was doing science journalism, had heard of any kind of science that these kind of companies were doing. And that may have been the culture at the time. Maybe they weren't vocal enough, and maybe they are more vocal now. And maybe that's why companies like British American Tobacco decided that they needed a science comms function and that they needed to be more transparent and talk more about the kinds of science that they did do.
So tell us about that job working for British American Tobacco as science communications.
Well, it was a difficult job because you were starting from ground zero. So there was a lot to be done internally in terms of building the structures. But also, as a person who had been a science journalist, I was used to people wanting to talk to you. So scientists would want to talk to you, especially if they thought that you were interested in what they were doing, and you might potentially report on it in a high-profile publication like New Scientist, for example, which I used to write stories for. And so by contrast, when I went to British American Tobacco, there was this automatic assumption that because you worked for a tobacco company in science or in a science-related function, that you might necessarily not be doing it for the best reasons, which is very different. I think if you look at other controversial sectors like pharmacy or energy, people do not assume that the scientists who work for them don't do it with good intentions. But it was often the case that that's what people perceived about scientists who worked in the tobacco industry. So it was a very, very different way of interacting with scientists and looking at the way they interacted and responded to me as a person working in a science function in this sector. So a lot of doors were closed to you know, that I hadn't experienced before, obviously. And it was a surprise.
Your former colleagues that you worked with in science reporting, what was their reaction?
I think they were very surprised, some of them. But for the most part, I have to say, the science journalists were quite pragmatic. I can't really think of anybody who wasn't sensible. But it's often it's the other scientists that have the problem, and not least because of the pressure they come under from their funders and a lot of external push on them not to engage with tobacco scientists.
So the impression was, or the implication was, that you went to the dark side.
Yes, absolutely. And I think it's an unfortunate impression of the scientists who worked in this sector, because I think like any scientist or anybody who studied science, they do it for the love of science and because they want to progress the science. And it's no different for the scientists who work for these companies.
Let me ask you, Dr. Murphy, are nicotine vaping products the answer to the smoking-related disease and death?
If you accept that people want to use nicotine, and people are likely to want to continue to use nicotine, and it is something that some people, aren't comfortable with. But if you do accept that reality, you need to decouple that nicotine from smoke. You need to decouple it from the thing that's doing harm. And that's not a new idea. We're all very familiar with the Michael Russell quote from the 1970s, where he talks about people smoke for the tar, or smoke for the nicotine, and die for the tar. So we're all very well aware of that. And also we're all very well aware of well-established products that have decoupled nicotine from smoke. And they're nicotine replacement therapies, which have been around since the 1970s. So it's not a new concept. But I think what the new thing is that these products seem to be, or the evidence suggests that they're very much more effective at helping smokers to get off cigarettes, get off smoking, than the more traditional NRTs. That these products are giving consumers more of what they want. Therefore, you're seeing a change in this whole dynamic. So, are they the answer? There probably isn't the answer. They are an answer, or maybe one of several answers, because there is a whole category of products, and I think they all have potential, and not everybody wants the same thing.
Is there any question that smoking damages your health?
No, there's no question that smoking damages your health. I mean, we know it causes cancer, it causes, heart problems, it restricts blood vessels. So, it impacts every organ in the body, including the brain. There's no doubt about that.
So for decades, tobacco companies try to create a safer cigarette, to combat that harm. Was the safer cigarette a pipe dream?
Well, trying to create a safer cigarette it's definitely a noble objective, that's for sure. But as a chemist, I would say it's not as simple as it sounds, because despite the fact that the cigarette is a simple product, I mean, it's basically dried leaves rolled up in a piece of paper. The chemistry of smoke is really, really complex. So it's not as simple as saying, oh, here's the smoke, let's see what the bad stuff is and take it out and then it's fine. That's not how it works. If you take a cigarette and you light the cigarette, the temperature at the tip of that cigarette is going to be 800 or 900 degrees. And then you create a smoke, which we know has thousands of compounds. So it's like a swirling soup of compounds that are interacting and reacting with each other, banging into each other, breaking up, or banging into each other, making bigger molecules. So you have this whole swirl of chemicals. You then draw through the stick, which is really dry, and the temperature drops really rapidly. And then you go into the mouth where it's moist, and then down into the lung, and you inhale it deeper and deeper into the lung, which is also moist and dark, but also the space is getting tighter and tighter. So now you've increased the pressure. So you've introduced high pressure into the mix as well. And as we know with chemistry, when you change the environment, you change the reactions, you change the compounds and the results of those reactions. So all these different things are happening all the time. And this smoke is what you call a dynamic mixture. So when you start interfering with that dynamic mixture, it's very difficult to predict what's going to happen. So if you say, for example, I've decided A, B, and C are the bad things, we need to remove them. And then if you imagine that like a lumpy mattress where you start pushing down the lumps, and then all these other lumps start to appear, it's very difficult to predict what's going to happen, what's it going to do, what's going to produce, and what are the potential negative outcomes that you couldn't predict and you couldn't know. So tobacco companies did look at one stage at trying to produce a safer cigarette. They spent hundreds of millions of pounds and many, many years. But I think the conclusion that they seem to have all come to at this stage is that rather than trying to modify a very complex mixture of chemicals, the smoke, you just need to remove the smoke and look to see how you can deliver that nicotine in a cleaner way that consumers want, and that's effective for what they want it for, which is to move away from smoking.
Well, and that's clearly the promise of vaping. Let me ask you, if you take that process, the chemical reactions, the deep lung inhaling, the small spaces, the high pressure, and all of that, how does that compare to the vapor? When, the heating element vaporizes the liquid, it goes in your mouth, it goes into your lungs and down. How, is there any similarities between the vapor and the smoke?
Well, the vapor, for a start, is going to be very much less complicated than smoke. So tobacco leaves are organic. They're very complex already. And then you light them, and then you produce a whole soup of complex compounds, like I said. The vapor is produced from an e-liquid, which is much simpler by comparison. So it's got, four major components, PGVG, which is the diluent, water, flavorings, and nicotine, if you want nicotine. So you're starting from a much simpler base at the beginning. And when you heat that, you produce an aerosol. And of course, there are things in it. It's not fresh air. But, you know, when you study the chemistry of the smoke versus the vapor, you can see that they're massively reduced in complexity. And, you know, there are things in there. We know there are things in there. But when you measure them and you measure them against what you know to be in smoke and what's thought to be harmful in smoke, you can see that there are fewer and much less toxicants in the e-cigarette than there is in the smoke. And depending on what list you look at or how you measure it, you can see reductions of up to 99% in the vapor compared to the smoke.
That's got to make a difference.
Well, it should make a difference, but of course, you can't just assume it makes a difference, which is why companies have such complex, what they often call assessment frameworks to assess the impact of that vapor versus smoke. And they go through a whole series of tests. And those tests, of course, start with the simplest test, which is let's understand the chemistry. Let's analyze what's in the smoke versus the vapor. Then let's look at how that impacts cells in the lab. What does the vapor do versus the smoke versus air? Let's look at how it impacts switching. Does it help people switch? And let's look at how they differ in what people are exposed to when they use them. Is a person exposed to less toxicants in vapor versus smoke? It's not a given just because you've reduced certain things, so you need to look at it. Have you reduced exposure? And then over the longer term, has that reduction or has any reduction in exposure that you've seen resulted in any impact in terms of health outcomes? When you're thinking about these things, you can't just assume that it's going to make a difference. You have to demonstrate that it's making a difference.
We hear opponents to vaping all the time make statements that, you know, e-liquids are toxic, that e-cigarettes are toxic. They use the term toxic all the time. From a pure chemistry point of view and understanding the science of it, are they toxic?
The important thing is that you're comparing smoke and vapor. So the vapor with the smoke. Vapor is definitely it's not fresh air. You are heating chemicals, therefore you are going to get chemicals in the vapor. And the lungs are very delicate, so anybody should be very thoughtful about anything that they inhale into their lungs. But if you are a smoker, your consideration has to be the difference between the smoke and the vapor. And if you listen to public health and you listen to people like Public Health England, which everybody quotes, but also if you look at what Health Canada says, if you look at what the New Zealand government says, and even what the US says, there is a difference, a big difference between vapor and smoke. And even if you think about the PMTAs that the FDA has awarded, they make the point of saying they've awarded these PMTAs on the basis that these products are appropriate for public health and that they have shown that they have a much reduced toxicological load and that is likely to be much less risky for the user.
This forces me to ask this question. Here in Canada, the federal government made recreational use of marijuana legal. The government sells joints that is the leaf wrapped up in paper, and it's okay to burn it. So, and you don't need to have been a prior marijuana smoker. You don't need to have been a prior tobacco user. You just need to be a majority age to decide to then consume marijuana through combustion bought by the government. So I guess what I'm saying is, why do we have to be so coy around vaping? Fresh air isn't, vapor isn't fresh air. Well, yes, but neither is marijuana smoke. And governments all, are allowing that, making money off of it, selling it all the time. So why do we have to be so delicate around vaping when discussing potential harms?
Well, I suppose what a lot of people would say is that it hasn't been around as long as smoking, and that's for sure. The cigarette rolling machine was invented, I think, 120 years ago or something like that, and cigarettes haven't changed very much. But we know from, decades of experience, real world experience, and many deaths that cigarette smoke causes death and disease. And anything that you burn is is potentially catastrophic if you're inhaling it into your lungs. It's, you know, like sticking your head in the fire every day and inhaling it for many years. I think there's always a worry. It's like with COVID vaccines. People sometimes take the view, oh, we don't know what it's going to do. But then what's the alternative? So is the alternative to continue smoking when you have, you know, many groups, like I said, like Public Health England saying these products, and you know, I think they were probably being cautious when they said these products are 95% less harmful than smoking. So again, you know, you have to go back to, so what are you trying to achieve? And who is it that these products are for? And they're for smokers.
Why are nicotine vaping products only for smokers? It seems to me that we're boxed into that because of the opposition. And so we say, well, it should then only, if you are a smoker, you can use it. But if you've never smoked, you shouldn't be using it. It's too dangerous. But here's a joint.
Well, like I said before, you know, if you accept that people want to use nicotine, but you have to accept that, well, then, you know, you can be maybe pragmatic about vapor products. I think there is an issue for a lot of people about addiction in and of itself. So, you know, people would often argue about what is the definition of addiction. Is something addictive just because you're addicted to it, or is it addictive and a problem because it's addictive and it potentially does you harm? And I guess that's a question that people are going to continue to ask and debate.
You mentioned cells in tests. So, you know, pushing smoke onto cells and seeing the reaction on cells. When those tests are done when it comes to vapor, is the result similar or different?
Well, you will find that there are a lot of these kind of tests have been published. I mean, for example, when I was in British American Tobacco, I would have written a lot about the kind of testing that they were doing. And, you know, they did these kind of tests to look at cell stress, DNA damage, and things like that. And the idea was that they would use cells in the lab and then expose, you know, divide them up, expose some to smoke, some to vapor, and some to air. So, you know, the exposure to smoke had a very definite effect on the health of cells, and a lot of times they would die, and sometimes they would depending on the type of cell and the type of test, but sometimes they would look very confused, going around in circles, like they didn't know where they were, so to speak. And then when you look at the vapor and the air, oftentimes and most times there was very little difference. You couldn't really tell the difference. Now, does that mean that vapor has no impact? No, it means that there was no impact seen in these studies in the lab. But is it valuable to do that? Yes, it is, because it adds to the weight of evidence, because no one test will necessarily answer the question. But those tests add to all the other types of tests that you can do, whether it's on the chemistry in the lab or on the people. And on the basis of those tests and those cumulative results, then you can make a determination as to the likelihood that product, that vapor, is going to be less harmful or less risky than smoking and cigarette smoke.
Is nicotine carcinogenic?
No, nicotine is not carcinogenic. And that's not me saying it. I mean, if you look at, for example, Cancer Research UK's website, and they're very clear, and, you know, it says there nicotine is addictive, but it does not cause cancer. So nicotine is not carcinogenic.
Does it harm teens developing brains?
Well, I mean, you hear that all the time, but you have to ask yourself, and you have to remind yourself that at one time in the world, almost every man smoked. I saw a statistic recently that at one stage, 96% of men in the British Army smoked. So much like anything else, you look back at real world experience and you see, you know, what happened. We know what they did. We know how much they smoked. We know that, you know, it was common. My father, for example, I think he started smoking when he was 12. So you have to ask yourself the question, if it's the case that nicotine harms the developing brain to the degree that we are told it does, what would we see now? What would we have seen in past generations? Did we see it? I think the answer is we didn't see it.
Dr. Murphy, now you also worked for a time at Juul. Tell us about that.
I did work for a time at Juul, and now I work for another company called ANS. And they're, of course, very different to, we'll say, old school tobacco. The products are very different, therefore the companies are very different. We've said already the cigarettes are quite simple products and old-fashioned. I've been around for a long time. They haven't changed really since they were invented with the invention of the cigarette rolling machine. And again, I repeat myself when I say dried leaves rolled up in a piece of paper. So you could say they're basically an agricultural product, right? So very simple. So now when you talk about companies like ANS, we're selling a technology. So we're selling a technology that's changing all the time, it's getting better all the time. So in order to be competitive, you have to be innovative, you have to be fast-paced. So it's very, very different. And I think it's an exciting area to work in.
Let me ask you, why is there so much confusion around the science on this issue?
There's a lot of misinformation. That's one thing. And I think that if you consider the anti-tobacco lobby, what was anti-tobacco and then became anti-smoking, also became anti the tobacco industry. And I think by virtue of the fact that vaping has been so linked to the tobacco industry, I mean, they didn't invent it, but they had the resource to make it go mainstream. So it's very, very linked to the tobacco industry. And also, it doesn't help that they're called e-cigarettes either. I mean, that's kind of unfortunate. They're linked back to cigarettes. So again, I think vaping is now a victim of some of the legacy, we'll say, of the credibility issues that the tobacco industry arguably created for themselves. And now the vaping industry is, potentially suffering from that association and connection.
So Dr. Murphy, after working as a science journalist and then spending a decade working with Inside British American Tobacco, talking with the journalists, working on behalf of risk-reduced products, now taking a step back and looking at the mainstream media, are they helping today or hurting today when it comes to tobacco harm reduction?
Well, I think it's clear that they're mainly hurting. I mean, you could read the same paper today and tomorrow, and today they'll tell you it's good and tomorrow they'll tell you it's bad. I mean, from my point of view as an ex-journalist, it doesn't smack of good journalism. It smacks of cut and paste, laziness, that's convenient, and it feeds the appetite for clickbait. And there's also, of course, with the internet and clickbait and instant news, there is a pressure to always have something new. And I think, of course, the go-to is the sort of David versus Goliath, good versus evil. And, a boring story is not an interesting story. And, the way they say no news is good news, but also no good news is news. So it's very difficult to get a positive story about anything, including vaping, I think, into the mainstream media. The other issue, of course, is the competition, because science media works in a different way to other kinds of media. So it works on the basis of embargo. So if there is very exciting science news, everybody is told you can't talk about it till 2 days' time. Can you imagine saying that to a political journalist? This is, a brilliant story, but you can't say anything. It wouldn't work. But it works in the science media, so there's a kind of control about what kind of science is released. And if you think about that engine, there are so many peer-reviewed journals that are very high profile, have very high citation indexes and very big press offices. and fantastic research being published in those papers. And they have, a press engine that pumps out fantastic research, and it is fantastic research. There is so much competition to try and penetrate, that wall of scientific data, to try and have your voice heard, which is difficult for anybody with that amount of noise, but even more difficult, I think, for somebody who's working in this area.
Dr. Murphy, I know you'll be hosting a panel discussion titled 10 Years of Science, What Have We Learned? At the Global Forum on Nicotine, the annual conference on safer nicotine products and tobacco harm reduction. GFN is coming up again this June, from June 21st to the 24th. Let me ask you, why is an event like GFN important?
Unlike a lot of other conferences or, platforms that say, we're truly inclusive, we want everybody to come, I think GFN really does want everybody to come. Even the media and anti-tobacco lobbyists be very welcome to come. But you also have, a great mix of academics, industry people, of course, students, regulators, but also importantly, and I think this is what differentiates it from a lot of conferences, is you have a lot of consumers go. So you have consumers and consumer groups. And so the consumer, I think, is often the great forgotten stakeholder, the most important stakeholder. And you have so many people, including academics, who talk about, great talk about the consumer, who they're notionally doing all this for. And at the same time, don't engage with the consumer, don't listen to what they have to say, and don't involve them in any of the processes or discussions. But the GFN is somewhere where you will see a lot of consumers engaging with the people who make the products that they consume and the regulators that create the rules in which they exist.
Final question, Dr. Murphy. Is there one message you could deliver to your colleagues in the scientific community? What would that message be?
Well, if you say you're a scientist, you need to act like a scientist. Scientists and science are supposed to be objective. So I would say, be objective, be pragmatic, be sensible, have an open mind, and look at the data.